programming, we need to first identify a couple of things. So we are going to label, or I guess just figure out what our general problem that we're trying to solve here, what our inputs are, what our outputs are, and how we control those. So we want to lay those out in some type of format. So in this problem, first I'm just going to identify what those things are. So I'm going to look at all my inputs. If I look on my screen here, I can see that my inputs are definitely, I have an open push button, I have a close push button, I have a stop push button, and I also have two limit switches. I have an open limit switch, which comes on when the that basically indicates to me that the door is all the way open. I have what's called a closed limit switch, which indicates to me the door is all the way closed. Those are basically my 5 inputs that I have to work with. Now I also have some outputs. For these, I have the important ones are basically a motor which goes in both directions, motor up, which is for open, motor down, which is for close. That is an output. Those are things that I control with my program. That's probably one device just running in one direction makes it open, running in another direction makes it close. I also have some lights, which are, I have an open light, a closed light, and what's called an ajar light. Ajar means it's neither open nor closed, it's kind of in the middle. And that is basically what I have for inputs, outputs, and basically, yeah, that's my inputs and outputs. So I want to list all that stuff at the beginning here. Next thing I'm going to do, I'm actually going to figure out how do I make things move. So for starters, what I'm going to do is write down some basic rules here. I'm just going to say to open, I'm going to say press the open PB, then open motor, open motor comes on. Let's say to close, I'm going to press the close PB, the close motor comes on. So that is very basic, simple form of what my program could do for starters. So basically I press a button, the motor's going to move in that direction, make the door move in that direction. So let's try actually coding that. I got to know a little bit about my addressing and a little bit about coding to make this happen. But basically, I want to translate what I've just written on paper here into code. So press the open PB, then the open motor comes on. So what that's going to look like, that is basically, if that is on, then this is on. This is going to look like, if this is on, then that is on. That's basically what that looks like. So let's make that happen, and then we're going to test it. So I got to do this. That's been my basic structure that I have here. For these instructions, I can just drag my address, so I'm just clicking there and dragging. That places the address there for me. That's my open button. That's my close button. That's my motor up. That's my motor down. Okay, so we have our logic structure drawn here. Our addresses we just drag over. Whenever we draw these things, we're always going to want to document what we're doing here so we can tell what's what. I can't tell what these things are just by looking at them. So what I'm going to do, right click, go here to edit symbol. I'm going to put a name on this. So this one was the open PB. I'm going to do that. Call this one the close PB. This one I'm going to call, this is the motor up. This one we're going to call motor down. I'm also going to put over here, click out here, and I'm going to put a run comment out here so I can just tell what this group of logic is doing. So I'm going to call this motor control. So this group of logic below this comment here is all controlling the motors. So that's my program so far, basically 2 lines. I'm now going to download and run my program. My program is actively running. So now what should happen is if I push the open button, my door should open, which you can see that it does. And you can see that the open button here turns yellow when I push it. Whenever I'm pushing the button, it is turning yellow. That means that it's on, and my logic is running. And if this is true, then this output will come on as well. Turning on my motor, you can see my motor turning. Makes the door go open. If I take my finger off this button, this goes off, motor goes off. And same way with the close button. If I push the close button, the door will close because the down motor comes on. So, very simple program for just 2 buttons, open and closing. Motors only run while I'm pushing the buttons. So, that's all well and good. Now, but we have some problems that we get into with that. So, first problem as we show here, as we run this up, if we hold this button down and keep on going past the end when the door is all the way open, boom, if we run too far, motor catches on fire because we've basically driven this thing through the ceiling. Same thing with on the bottom. If we drive it through the floor, hold the button down, motor catches on fire because we've driven it through the floor. So, we need to put some logic in here that's going to fix that and prevent us from ever being able to do that. So, we have some switches here which can tell us that we've actually gone to our over travel limit. So we want to use these switches to say that once you reach all the way down, don't let that motor go any further. And once we've reached all the way up, don't let that motor go any further. So we need to add those switches into our logic here. So let's look on paper how we would actually write that out. Typically when we're writing logic, we're going to break our rung down into let's say we got a whole bunch of stuff here like this, and then an output. Typically the way that we arrange things, we have some logic over here, and some logic over here. Typically the way that we'll do this, this is going to be what makes us go, and then to the right, this here is going to be what makes us stop. So on a line of logic, we're typically going to have something that looks in a general structure like this. Left-hand side is kind of what makes us go or continue. To the right is going to be kind of what makes us stop. And then here we're going to have our actual output. So in this case, what we've got we have our push button. We're going to add that limit switch in here. So basically, push button makes us go, limit switch makes us stop, motor is our output. So let's try coding that. So we'll try coding this. We're going to add in our limit switches here. So remember, we have to go back into program mode. We're going to flip this over, and we're going to add in our limit switches. This is this one. The open, we want it to stop when we actually all the way opened, and the close when we're closed. So let's download this and try running. Now we are going to open, and you can see this is on right now, which is good. That is lit up yellow. That means that switch is okay. It is on. And as long as I have my continuity all the way across there, so I have this is good, my output should be good. I'm able to do that. I'm going to hold this button down, and you can see once we hit the top, it is not going to be the open button that stops us. It is this door open limit switch contact that goes away. That is what's preventing my rung from happening right now. That's what's preventing me from moving. Now, if I try to move in the closed direction, you can see right now I'm pushing this button, and for some reason the door won't close. Now, the reason that is not closing right now is because I am getting signal from this door close limit switch that tells me you can't close because this limit switch says so. Now, the reason this is happening is because this limit switch and this limit switch actually operate differently. If we look at this text when we hover over here,
This says not activated false when door is fully open, else activated true. This one says activated true when door is fully closed, else not activated false. So these actually work opposite each other, so which is very, very confusing at this stage of the game. But because of the way these switches are physically created, this contact here actually needs to be the reverse type of contact. So instead of being a normally open contact here, this actually needs to be a normally closed or examine if off contact. So we are going to change that to this. And now, when I put myself into run mode, you'll see that this is now lit up good, and it's just waiting for the close push button to come along. Now I can go, and we can go all the way down till we are hit the close position. Once we hit the close position, it'll be that limit switch that actually drops us out and stops us. And there we go. So now we have some improved logic that prevents that over travel condition from happening. We cannot drive into the floor, we can't drive into the ceiling anymore because these limit switches actually stop our travel from happening.
Okay, so next phase we're going to do here, we've got our motor moving, or our door moving up and down with the push buttons. We've also got it stopping when we hit the end of travel. What we want it to do now, we want it to operate kind of like the windows on your car, the power windows. We want to say, I just want to push the open button, and once I do, I want it to open, and I want to be able to take my finger off the button and have the door continue to open until it hits the complete open position and then just stop on its own. So to do this, we need to do what is called a seal circuit. And we're going to use these circuits over and over and over again in this course and all of the logic programming we're ever going to do. And use lots of different seal circuits. So the way a seal circuit works, basically we have something that looks kind of like this. That is the general form of a seal circuit. So the way this works, we have something that tells us to start, something that tells us to continue, and then something that tells us that we need to stop. So basically the same logic that we had already. We've now added this this section here, this continuation part of the logic in here we've just added. So we've thrown that in the mix here, and what that does is that basically once we start our circuit, if we kind of illustrate how this stuff works, power flow is going to go like this. Once we hit our start button, we get power flow through here, we're good. We get all the way to here, that lights up our circuit here. When we take our finger, what we need to do is we need a way to basically bypass this start input once we take our finger off the button. So we need this continue input to come on basically once we start running. So once this output comes on, we want this branch to be active as well, so that if we lose this upper branch, we still have a continuous path all the way through that is going to keep our output active, and this is what a seal circuit does. So in keeping with our tradition here of writing out in words what we're trying to do. Now, if we want to open, where you're going to say open if open PB or already opening. So once we start opening, we are going to continue opening. So let's look how this is going to work in the logic.
Okay, so I've got my logic over here. We know that right now this operates. I can open, I can close. That works right off the buttons right now. So I'm going to modify this logic to basically seal this in so that I don't need to hold that open button on in order to keep the motor going up. So the way I do that, I'm going to add a branch. So the branch is right here. I'm going to rearrange this, shove that over there, and I'm going to add another condition down here. So what should this condition be? This is basically my continuation. So I want to say if I push my button, that's going to start my motor going up, but I want this to stay on if I'm already moving up. So my best signal that I have that tells me that I'm already moving is actually this output. So I can use this output address as an input instruction here. So all I'm going to do is going to drag that address over here. And what I've got here is the basic form of a seal circuit. I have some type of starting action. I have my output. I'm using that same output address here. And then I'm having something that breaks that circuit here. So if we download this now, put myself into run mode, you'll see that now when I push this button, I can take my finger off the button, and because this stays sealed in, this will keep opening as we move along here. That's going to keep on opening on until we get to the top. The only thing that's going to drop it out is when this happens. That goes off, that breaks this, that breaks the seal, and opens this up, shuts the motor off. To move down, I actually need to hold that button because I'm not sealing this one yet, so I need to hold that one. But once again, to go back up, it'll move up on its own. So let's look at a couple other situations here that we're going to get ourselves into. These are things that you might not think of right away, but once you start trying to operate a system like this, are going to become pretty evident that these are problems. So we've got our logic here to go push the open button, door goes up, and you see I can adjust the speed of our scan here to make everything happen faster or slower. Close, open. If I change this speed, things happen faster or slower. So I can mess with the speed to as I want to see things happen in my simulation here. Let's look at this situation. Let's say I am opening, and as it's opening, someone hits the close button. What happens? So you'll notice my motor caught on fire. So that is bad. If we look at our logic over here, you will see that my motor up output is on, and my motor down output is on at the same time. This is a situation we need to avoid. So basically,
I'm telling my motor to go forward and backward at the same time. That is a very bad situation, causes my motor to catch on fire. Now hopefully in a real world situation someone is figuring this out before the motor catches on fire and takes measures to prevent it, but a lot of times you are asked to put in logic to fix a real world problem that no one saw in the design phase. So we need to add some logic in there to prevent that from happening. Another thing you'll notice is that once I start to open, I have no way of actually stopping this until it reaches the top. Same with on the way down. Once it starts in motion on the way down, I have no way to stop it on the way down until it hits the bottom. So it would be nice to be able to use this stop button to actually, from opening it, let me push the stop button to actually stop it where it is, so it just sits there in the middle. So I'd like to add that in as well. So let's look on paper what that would look like. Let's think it out, and then we'll modify our logic.
So our logic is now going to look like this. We're going to have a couple things. We're going to say to start, continue, and some things that make us stop. So to start, we're going to say, let's talk about the open motion. So this is going to be the open push button. In order to continue, we're going to continue if we have the open motor is running, and then we are going to stop for a bunch of different reasons. Now we will stop if we have the close push button, if we have the stop push button, if we have the opened limit switch, or if we have the close motor. Let's add all of those things in here. So what our logic will look like, we'll basically have, that's our start. Let me draw this in the colors here. Our start button, we're going to have our continue branch down here, and then we're going to have a bunch of different things that actually make us stop. So as long as we don't have the close button, stop button, open limit switch, we don't have the close motor, as long as we have all those things, we can actually run. And that's kind of what our logic is going to look like on the page right there.
So as we drew out, what we're going to do here is we're going to modify our logic. We're going to add some more stopping conditions in here. So we've decided that we're going to add the stop button. I believe if we hover over this, this stop button is going to say is a normally closed push button. I just know right now, just by looking at that description, that I believe this is the correct contact for that. We'll know for sure when we actually try to run it. I'll call that stop PB. And we're going to copy and paste that down here as well, because it's the same instruction we're going to use both ways. The other thing we're going to do is we're going to say this can only run if we are not going in the opposite direction. So not the opposite direction. So we can only go motor up if we are not trying to go motor close. So in this way, we cannot have both of these outputs on at the same time. We cannot have both of these outputs on at the same time. That prevents that motor catching on fire condition that we just had. So let's give this a try. Download, run mode. You can see these are lit up right now, which is good. If I push this stop button, they should go away. So basically this button has to be not pushed in order for this to work. And now we should be able to see close button. If I push stop, it will stop where it is. Stop now breaks the seal. I can go close, stop. I can go open, stop, open, stop. And if I'm closing and I were to hit the open, that does not catch me on fire. That does not allow the motor to go in the other direction. It does not make me catch on fire. If I want to make it go in the opposite direction, I need to do a stop first and then open, or a stop and then close. That is what my logic is doing right now. That's the way I have it written. So let's look at a couple other things. Let's try to incorporate our lights in here. So the lights are basically just going to report our status of where we are at in simple form. So what tells us where we are at? We have 3 lights, basically open, shut, and ajar. We will turn on the open light when we are actually open, or turn on the shut light when we are closed. We'll turn on the ajar light when we are neither open nor closed. That should be pretty straightforward because we should be able to read the position of the limit switches to tell where we are. So let's look at that. Let's add a couple lines of logic in here. We'll see if I get these right. So we're going to say if we are I think that's is going to go this way with this address. Door open is going to give us the open light. Door closed will give us the shut light. And let's try these out. We'll work on the ajar one next. So right now, this is lit up. This appears to be correct. We are shut, and we are reading the shut light. Let's try opening this. Shut light goes off as we are opening. And then we should see open light come on when we actually reach the top. So these are working correctly right now. So we wrote those correctly. Let's put a comment on here. And we're just going to call this light control. Let's do that. So you can look at this program right now. Where are my motors located? I have this section here that's for motors. I have this section here that's for lights. Now let's put in our ajar light. Now this one's going to be on. Let's think about how this one works. If we are neither So if we are not closed and we are not open, so basically the opposite state of this one and the opposite state of this one, we need both these conditions to be true. That will give us the ajar light. Let's see if that works. So we're open right now and then anywhere we are in between, we should get the ajar light, which is what we have there. And we should go from ajar to shut when we reach all the way to the bottom. Okay, so that is our lights working properly. Now, one final thing they wanted us to do here was actually make these lights flash. If we are opening, let's flash the open light. If we are closing, flash the closed light. And if we stop, I think it's if we stop part way, we're going to flash the ajar light. Let's try that. So let's just flash the open and closed for now. So to do that, we have a bit that is defined in our logic that is called S2:4/4. This is a status bit. And what this bit does, I'm going to run this logic here. You can see what this does. This bit actually flashes at a set rate. There's a bunch of bits in our that are defined in the PLC that are going to flash at a bunch of set rates. I can show you a couple of them here. So just a couple of different addresses, and these are all going to flash at different speeds. If we look at all these going here, see those are all flashing separately. I'm going to do another one here with a 6 on the end. I think this one flashes at a pretty nice speed here. It's a nice slow flashing. This is the one I like to use. It's a pretty decent flashing rate. So we're actually going to call this one our flasher bit and use it in our program. So what we're going to say now is that if we are all the way open, we're going to hold this on solid, but we are going to flash that if we are actually in motion to open. So we know that we're in motion to open if we have the up output on. So we're going to do that, and we're going to do the same thing with our closed light. Do a copy, whoops, and a paste to the right, and our closing address there. Let's try this. So now as we open, we should get our opening flashing. That should go solid when we are all the way open. And then flashing as we're shutting, and go solid when we are all the way shut. And that is the majority of our logic to do the garage door opener. We've got one last piece of the puzzle here they're asking us to do. So what they want to see is they want to see when we are opening this door, if we push the close button, they want to see that just stop, but not restart and go in the opposite direction. They want it to just stop. If I just push, if it's opening, they want it to stop with the close button, and then wait until the close button is pushed again, or the open button is pushed again in order to get motion again. So if we start to code this, you might think that,
all I have to do is basically say, as long as I don't have the opposite button in here, does this fix it? That gets us partway there. So what I just added there was basically said, if I'm open, I'm going to run, I'm going to break my conditions if I get the close button. So let's see, if I'm closing and I push open, it goes in the opposite direction. So closing, I push open, it'll go in the operation. I put close, so basically the opposite button will make it turn and go in the opposite direction. But what I want to happen is for it to actually stop dead and wait for me to push that button a second time for it to continue. So that is a real trick to doing this. So what we need to define here is we actually need to define a kind of a starting condition and say that we cannot start our circuit unless we have these starting conditions met first. So we are going to ignore our button pushes unless we are in a starting condition. So if we are already moving, we're not going to accept button pushes, but if we are moving, we will accept button pushes. So let's see how we can do that. So there's a couple ways to do this. We'll look at one way first. I'm going to add another line here at the beginning. I'm going to call this start conditions. Now we're going to define our start conditions as I don't have either button pressed and my motors are not running. So I'm not pushing the open, I'm not pushing the closed, I'm not trying to run up, I'm not trying to run down. That is basically my starting condition. So that's basically what it looks like before I do anything. So if this is all good, then I'm okay to accept a button push. So what I'm going to do now is I'm actually going to add a bit in here. It's going to be a latching output bit. That is this instruction here. And for the address of this, I'm going to use an internal address. Now an internal address is an address that doesn't link to a real-world input or output. It is basically an internal memory location that is basically kind of an intermediate step in your programming. So in this language, we define these as B3. I'm just going to put B3/0. That is the very first binary internal memory address. And I'm going to call this start conditions. So this is kind of an advanced, a more advanced step we're actually using in this lab. But this is a kind of our first adventure with internal binary addresses here. So we're going to call that our start conditions. Now whenever we're using a latching bit, we also need to make it unlatch. So we're going to add another line here. And we're going to add in some conditions of how this is actually going to unlatch. So in order to unlatch this same address, this is basically working like a flip-flop. If you want to remember your Boolean operations. So we will unlatch this condition whenever we have the motor actually running. So if we are running either forward or backwards, we'll say that we are not in our start conditions anymore. I think that should do it. Now the other thing we need to do is we're going to say that we must have our start conditions enabled. This latch must be on in order for us to accept button push. And what that should do is that should make it so pushing the button when we're traveling in one direction should stop us until we actually stop our motors, release the buttons. That should reset our start conditions, and now we will be ready to accept a button push again. Let's see if this works. Downloading, going into run. We are opening. Now if I push close, it should stop. So that stops it dead. And then I push close a second time, and that will close. If I push open, it stops dead. And then if I push the open again, you'll see right now I have my start conditions. If I push open and I'm running, I do not have the start conditions. So if I push a button right now, nothing would happen, other than it stops my logic. And we're stopped. Now I have my start conditions again. I'm ready to accept an open or close button push to get us moving again. And I can continue to move. So that is all of our logic for the garage door